Oh, sorry about that last one, people. Okay, so, transporting carbon dioxide, we just need to know that it's dissolved in blood plasma, bound to hemoglobin proteins, and the bicarbonate ion and carbonic acid in the red blood cell. This whole, I don't know, I don't need you to know the specifics of this whole reaction, but there is an enzyme that is important. It reduces carbon dioxide. I just need you to know that the name of the enzyme is called carbonic anhydrase. So, okay. So pop quiz, people, let's do it this way to make it bigger. Aha. So according to this means this is another thing that's important. Decreased respiration. When you don't breathe as profoundly or deeply, it leads to a decrease in blood pH, means that your blood becomes more acidic. Increased respiration then would, obviously lead to the opposite, which is an increase in blood pH, which is more alkaline. So this has to do with hypoventilation and hyperventilation as well. I think we talked about it earlier in one of the previous videos. So please make sure that you know how to do this piece. Checkpoints. Please make sure you can answer these. Ooh, we have all kinds of cool stuff. Pop quiz. Please answer this. Now we're going to talk about regulation of respiration for the last little bit of it. So we're going to talk about what factors control breathing, describe normal and altered breathing patterns, and comparing hyperventilation with hypoventilation. So let's go on to that. Obviously, it's going to be the nervous system that controls your breathing. Fundamental respiratory patterns are going to be established by the nervous system. The main control center is in the medulla. That is on the test, I promise. The secondary center is in the pons, which modifies the medullary patterns. So the pons and the medulla actually talk to each other to regulate your breathing patterns. Dun, dun, dun. And the modification occurs by receptors detecting changes in the blood chemistry. Like we said, if you breathe less, or if you have hypoventilation, you tend to have a decreased pH versus a hyperventilation pattern, which lands you in a more alkaline pH. Respiratory centers, again, the pons and the medulla. Medullary centers set the basic rhythm. It sends impulses through the spinal cord and the diaphragm via the phrenic nerve. That's also important. And the intercostal muscles. That allows you to breathe without thinking about it. So there's the pontine respiratory center, modulates the basic rhythm, and the cerebral cortex overrides basic rhythm under conscious control. So you can actually, you have the medullary respiratory center that will cause you to have a regular breathing rate or respiration rate that's altered by the pons, which modulates it depending on what your internal needs are, and your cerebral cortex can actually override that for a short period of time, like when you hold your breath underwater or whatever else you decide to do. Central chemoreceptors, chemo means chemical, and receptors, so they're located near the medullary respiratory center, which responds to which chemicals? It's the raised arterial carbon dioxide level, so that's called hypercapnia. You need to know that. Hypercapnia increases the rate when the depth of breathing, because if you have arterial carbon dioxide levels that are higher, that indicates that the oxygen levels are lower than they could be or should be. So then you'll have increased rate of breathing as well as depth of breathing. So you can have more oxygen going through your arteries and veins, or no, not your veins, your arteries. Peripheral chemoreceptors are located in the carotid and aortic bodies. Please know that for the test. These are all really great pieces of information. They respond to oxygen levels at that are considerably below normal. Dun, dun, dun. So these are all of these receptors that you have that regulate your breathing. Chemical controls, the chemoreceptors, the central chemoreceptors are near the medullary respiratory center that responds to hypercapnia, as you can see here. So a couple things that you need to know about medical terminology when it comes to breathing is the PNEA ending has to do with breathing, and as you know, tachy means fast. Hyper also means fast, and hypopnea means that you are breathing less or shallowly, and you can also get bradypnea, which means slowly, like tachy and brady, and apnea is the absence of breathing, as in sleep apnea. So these are the normal rates: adults 12 to 20, children 20 to 40, and infants more than 40. Hyperventilation, high oxygen level and low carbon dioxide levels. Hypocapnia, it increases the blood pH or causes alkalosis. This is what hyperventilation will do. Hypoventilation will do the exact opposite. So the result in hypoventilation is hypoxia or hypoxemia. Hypoxia is the condition of low oxygen levels in the body. Hypoxemia is specifically that of in the blood. Which then brings us to more pop quizzes. You should definitely look at that. Phone ringing. Oh, that's exciting. Okay, good. Common signs of aging. This is important. Please circle, star, do whatever you have to do to this particular ditty. Tissues, normal signs of aging in the respiratory system or tissues lose elasticity, they become more rigid, they have decreased compliance and decreased lung capacity. Decreased compliance meaning that they're not able to expand and contract as much as they don't have as much give, so things become a little stiffer. You get increased susceptibility to infections, both because of decreased secretions and decrease in the immune system as you age, as well as because that's all a part of aging in and of itself. You have regular aerobic activity. If you do, it helps maintain a great respiratory function. It's the whole use it or lose it principle. So if your body feels the need to continue to have that capacity, it will. Let's move forward. In the pathology process called emphysema, you have compliance is increased, so your lungs get a little bit more floppy. And you have irreversible enlargement of the alveoli. They get dilated and they get larger. So lungs are easy to expand but hard to deflate. Pulmonary fibrosis, in that pathology, compliance is decreased, and you have because fibrosis means scar tissue, so you do not have compliance, you're not easy to expand anymore. So we talk about this process here. Says repeated stimulus leads to sequential lung injury, which then coupled with aberrant wound healing, right? So you just get genetic factors, different genetic issues, then it leads to fibrosis. This picture on the bottom left here, it's called clubbing of the fingernails and fingertips. So that actually is indicative of pulmonary fibrosis as well. In normal lungs, as you can see here on the top, you have normal airways in the right lung. You have the bronchioles there. With idiopathic pulmonary fibrosis, or IPF, you have damaged bronchioles and alveoli, and you see the fibrotic tissues. Therefore, you have greatly decreased gas exchange. I think that's everything. Okay. So there you have it in 5 different clips, and I tried to keep it under 15 to 20 minutes each because, attention span, really difficult to hold concentration for more than 30 minutes. I hope this helps you. I'll do the arteries and veins later on this evening, and hopefully that will help you as well. Have a good time studying. Bye.